over dx equals.
So let's solve it the way we know, and then I'm going to give you another way that's going to work out because the answer is not written the way I like it. So let's find the derivative. What is the derivative of tangent?
Secant.
Secant squared. Let me go ahead and get rid of this. So I have secant squared, and it's our chain, not chain rule. Oh, it is chain rule. Secant squared of xy. Oh, I need to bring it up. And then I need to go ahead and use product rule on the next one. Times the derivative of the inside. For the inside, the derivative of x is 1, and you keep the second piece. What operation separated the product rule? Plus. And then we keep the first one, which is our x. And since the derivative of y is 1, and it's not an x, what do I need at the very end?
dy over dx.
Good, dy over dx. That's a y. Then I have equal to, what's the derivative of the x?
1.
1. So, I would take all of this and distribute.
Oh gosh.
Somebody make her stop. Secant squared of xy times a y plus we have secant squared of xy times dx times cy over dx is equal to 1. And then I'm going to make dy over dx by itself, meaning we are going to move all of this to the right side by subtracting and divide it by the coefficient. So let's do that in one go. dy over dx. Now I'm taking 1 minus all of that first piece and dividing by the coefficient in front of the derivative. And the sad news is it one of our answer choices? No. Nope. How dare it, right? So here's another way to go for it. Let's rewrite this. Let's say I have secant squared of xy times y plus x dy over dx is equal to 1. Could I also divide the whole thing by secant squared of xy? Because really in the end it is this times this. So let's try that. We get y plus the x dy over dx is equal to 1 all over secant squared of xy. What is the reciprocal of secant? One over secant is the same thing as cosine. Sounds like it though, right? So all of this is going to be my cosine. So let's go ahead and make dy over dx by itself. So I'm going to start by writing out cosine squared of xy. So our rule is we're going to subtract the y and divide it by the coefficient. So minus the y divided by the coefficient x. Now do I see an answer choice here? Which one? There we go. E. Okay, 20 is our next one. And on number 20, we're actually looking at IROC is equal to AROC. Basically, the derivative is equal to the slope, or the average. All right, Emily, let's read number 20.
Let f be the function defined by f of x is equal to x plus natural log of x. What is the value of c for which its instantaneous rate of change of f at x equals c is the same as the average rate of change of f over 1?
So we have IROC is the same as AROC. So let's write out IROC. Then we have AROC. And IROC basically is a derivative. So if I take this function and find the derivative, that's going to give me what? 1 plus 1 over x. Okay, so that part is done. For the average rate of change, they gave us a range on here. So we have f of 4 minus f of 1 over 4 minus the 1. And when I plug that piece in, we're going to actually have to plug it back into that one. So we have 4 plus natural log of 4 minus, so 1 this time, 1 plus natural log of 1. Oh no.
Rafael, how are you doing this?
We are plugging in the 4 into the x's from the function, and then plug in the 1 into that function. All over, why not 3? Because it's a calculator portion, let's see if it will calculate it without me going on any further. So I need to make this equivalent to this one. So let's go to y1 and y2 and type this in. Grab a calculator if you need. Don't just watch me. Not going to be helpful. So grab one if you have a class set assigned to you. And be really careful with the parentheses. Haley, you don't want to type with me? And when you're ready, go to Zoom 6. Is it actually finding the intersection for y'all? Crossing at something?
Yes.
Ooh. You guys know why the second one is a straight line horizontally?
Because it's
Are there any variables here? It's a constant. But it's calculator allows, so we don't want to do all that extra work. So it's crossing at somewhere on the right side. So second calc 5, I'm going to go to the right side. And anywhere it's pretty close to the intersection, you can press enter 3 times. And it should give us how would I round that? How many?
2.164.
That's right, 2.164, and our answer choice, C.
Wait, how did he get?
I intersected
Oh, where it's like,
y1 and y2. Okay, then we're going to number 20, what was it, 3? All right, Ryan, let's read number 23.
Functions f and g are differentiable for all real numbers, and g is strictly equal. The table above gives values of the functions and their first derivatives at selected values of x. Function h is given by f of x equals f of g of x minus 6.
And the question?
If g to the negative 1 power is the inverse function g, write an equation for the line tangent to the graph of y equals the inverse of g of x at x equals 0.
All right, so we're finding the line that is tangent to, so basically a tangent line. We need a point, and that point consists of x comma y. So let's worry about that first. Which coordinate is already given to us?
2,
2, which is our
X.
x coordinate. To find the y coordinate, it's going to tell me y is equal to g prime of x. So when I plug in g prime of my x is 2. Is it 1? Everyone see 1 on there? Yes? So at 2 at the g prime we have 1. So we know that value is going to be 1. Okay, here's the only thing that might sound new. Underline the following phrase. G prime not prime. The inverse of g is the inverse of g. That kind of sounds redundant. But when that phrase is given to us, here's what we are allowed to automatically know. G prime of x. And when I take the derivative of that, it's going to always equal 1 over g prime of g inverse of x. Do y'all hear that too? Is it a game? Yeah, that is. Oh my God. Interesting. I feel like it's too soon for that, right?
About a month.
Maybe May, but not for us though, right?
After
Oh, absolutely not. All right, so on this one, we're plugging in the 2.
What are we doing after the AP test?
We got factoring.
After the AP test?
Yeah.
And it's no correction. Wait, what?
Oh, goodness. I'll keep updating the calendar. I'll make it bold. Okay, moving on. 1 over g prime of. What do we find for the inside? 1. So then if I go on further, we're going to go ahead and look at 1 over. If I look at g prime of 1, g prime of 1 gives me what number? 5. So that is our slope. So we're looking at y minus the y1 is 1 is equal to my slope, 1 over 5, times x minus the x1, which is 2.
Is that it?
And that is our final answer. Oh, y'all can't even see it.